So now we've learned about how to find the moments of a lamina. Now we got to find the center of mass. And of course we need the moments in order to find the center of mass, because the center of mass is, x bar, y bar, where x bar is the moment with respect to y over total mass m. And the y value, the y bar value, is the moment with respect to x over the total mass m. And of course m is the mass of the lamina. And the lamina's mass is calculated as density times the area of the entire lamina. And just keep in mind that mass is rho times the area, but of course area we have to integrate to get it exactly. So it's the integral from a to b of f of x dx. So now that we know that the moment with respect to y from prior video was rho times the integral from a to b of x times f of x dx. And now we know that area, or that mass here, full mass of the whole lamina, is rho times the integral from a to b of x, just f of x dx. And then if we refer to this component here as A, which is the area of the lamina, what you're going to get is that x bar is equivalent to 1 over A times m sub y, which is the moment with respect to y, which is the integral from a to b of x f of x dx. Now we can do the same thing for y bar when we want to find the y value of the center of mass of the lamina. We start with the moment with respect to x, which we found above, or in a prior video from this standpoint, as rho times the integral from a to b of 1/2, and then we have f of x all squared dx, and then the mass from right above right here, the mass of the lamina is rho times the integral from a to b of f of x dx. And of course we can go ahead and cancel our rows again. And since this denominator is just area, we know that y bar equals 1 over area of the lamina times the integral from a to b of 1/2. And then we have f of x all squared dx. So that is going to be how we find our center of mass of a lamina. So let's go and work with an example. So they want us to find the center of mass of a semicircular plate of radius of 4. So radius of 4 means I have x squared plus y squared equals 16, and then y equals the square root of 16 minus x squared. Now, I'm going to show you something real quick, but I'm going to do the math behind it anyway. This is the semicircle with radius of 4. It should make sense to you that the x value of the center of mass will be 0 here, because we have symmetry over the y-axis. I'm going to show you why that's true also. So let's start by solving for x bar, and of course I want this to be 0. But I basically want, first of all, I have to find the area of the mass. Since it's a semicircle with a radius of 4, we can just do pi r squared times 1/2. So 1/2 times pi times r squared gives me 8 pi. So it's a little bit easier when I don't have to integrate. So x bar is going to be 1 over area, or 1 over 8 pi, and then I need the integral from a to b, which in this case is -4 to 4, and I need x times f of x. And I can use u substitution in order to integrate here. I have 16 minus x squared is my u, it'll be -2x is my du. I'm going to let you guys work on that u substitution and know that when I do my substitution, I'm going to get -1 over 16 pi. Leaving out my limits of integration, I'm just going to have rad u du here, and then when I integrate, I'll get -1 over 16 pi, and then I'll have 2/3 u to the 3/2 which now I'm going to go and sub back in for my u. Negative 1 over 16 pi times 2/3 times 16 minus x squared, all to the 3/2. And I want to evaluate this from negative 4 to 4. In fact, I'm going to make my life easier, and I'm going to integrate from 0 to 4, and I'm going to double that area. So I'll put a 2 out in front, so using symmetry. But now I can see that if I plug a 4 in here, I'm going to get out 0. So 16 minus 16, all of this goes to 0. So my x bar does come out to 0. It's exactly as we thought it would be. So now it's time to find y bar. I'm going to go ahead to another page to find my y bar. I have lots of workspace here. So I have 1 over the area of my semicircle. Then I do need to integrate from negative 4 to 4, but I'm going to go from 0 to 4 and double my integral using symmetry. And then in this case, I need 1/2 times f of x squared. Well, f of x is a square root, so f of x squared is just 16 minus x squared. This is a much easier integral to deal with. So I'm going to, let's see, cancel out these 2's, and I'll have 1 over 8 pi, and then I'll integrate to 16x minus x cubed over 3, and I need to go from 0 to 4. So I have 1 over 8 pi, then I have 64 minus 64 over 3. Okay, and when I do that, I'm going to multiply it all out, and I'm going to get 16 over 3 pi, which is my y bar. So my center of mass for that lamina is 0, 16 over 3 pi.